we have learned how the brainer has classified the elements into triads. We also have learned that it was not found to be useful. The attempts of the brainer that was encouraged by other chemists to correlate the properties of elements with their atomic masses. In 1866, John Newlands, who was an English scientist, he arranged known elements in the order of increasing atomic masses. This name you will remember the law which we are going to learn now. That name of the law is on the name of the scientist John Newlands. And now we will learn Newland's law of octaves. So the brainer has made attempts, and then with that idea, this Newlands has arranged elements into increasing order of their atomic masses. Which type of elements did he take? How many elements were known that time? So that many. What did he do? Newland started with the element having the lowest atomic mass. We know what is the lowest atomic mass, right? Hydrogen has the lowest atomic mass. So he started from hydrogen and ended at thorium, which was the 56th element. So from hydrogen to thorium he did, and thorium was 56th element. What did he search? He found that every eighth element had properties similar to that of the first. What did he search? See, he arranged the elements from hydrogen to thorium. In what order? In order of atomic masses. In increasing order of atomic masses. And when he arranged it this way, then he got that first element that has similar property to that of eighth element, and this was repeated. Every first element that has similar property to the eighth element. Now when he started from hydrogen, this way he has arranged all 56 elements. So hydrogen, then we'll see horizontally, okay? Hydrogen, then lithium, then beryllium, then boron, then carbon, nitrogen, oxygen. Then we have F means fluorine, then Na sodium, Mg magnesium, Al aluminium, Si silicon, P phosphorus, S sulfur. This way all the elements he arranged in increasing order of their atomic masses. And he searched that every eighth element had properties similar to first element, and he compared these to the octaves found in music. Therefore, he called it the laws of octaves, and that is why this is known as Newland's octaves. Okay, he arranged these elements into increasing order of their atomic masses, and every eighth element has similar properties to that of the first one. So it is known as Newland's octaves. Octave means 8. It is known as Newland's octaves. Here in Newland's octaves, the properties of lithium and sodium were found to be the same. Sodium is the eighth element after lithium. Similarly, beryllium and magnesium have similar property. Although hydrogen is the first element, it has the lowest atomic mass. But Newland's octaves start from lithium. That we need to keep in mind. So, we'll start with lithium. Lithium will have similar properties to sodium. You see, below lithium only sodium is there. If you consider lithium as first element, then beryllium will be second, boron will be third, carbon will be fourth, then nitrogen will be fifth, oxygen will be sixth, then fluorine will be seventh, and what is eighth? Eighth will be sodium Na. So every eighth element will have similar property to that of the first. I told you from which element to start? Lithium. So lithium and sodium has similar property. Similarly, beryllium and magnesium has same property. Then boron and aluminium, carbon and silicon, nitrogen and phosphorus, oxygen and sulfur. This way, every eighth element will have similar property to that of the one. This is known as Newland's law of octaves. How did we get this? He arranged these elements in such a way that he got the same property for element 1 and element 8. Now we all know the basic musical notes in a scale, right? Sa, re, ga, ma, pa, da, ni, sa. That we all know, right? This basic notes. So this is similar to it. How? If we consider these first column hydrogen as sa, then next lithium column with re, beryllium column with ga, boron column with ma, carbon that is pa, nitrogen da, and o, oxygen that is ni. Okay, then again what will come once you finish the basic musical notes? Sa, re, ga, ma, pa, da, ni. Then again the next will be what? Sa, which means the properties of that will be same. Then again what will come after sa? That will be re. So you see the second column which is of re. So these elements will have similar properties. So here in this picture you can clearly understand what is the relation between musical notes and the elements. This is just for that it will be easy for you to remember that every eighth element will have same properties as one, as we have in musical notes that way. Newlands have given this octaves. There are advantages and disadvantages also. Now let us see what it is. It was found that the law of octaves was applicable only up to calcium. After calcium, every eighth element did not possess the properties similar to that of the first, which means you see in the third column we have third member calcium. So up to that only this law of octave was found proper. After calcium, if we see that the elements which are present, they do not possess same properties as that of the first. So this is the first limitation of Newland's octave. What it is? It was applicable up to calcium only. As we have already discussed that he took the elements which were discovered at that time, which were known at that time. So It was assumed that that time only 56 elements were existed in nature. It was also thought that many elements will not be discovered in the future. But later on, there are many new elements which were discovered and which are not fitted in this Newland's law of octave, because the new elements which were discovered, their properties are totally different than these elements. So this is second limitation. One more limitation of Newland's octave is, in order to fit elements into his table, what did he do? Newlands adjusted two elements in the same slot, but also put some unlike elements under the same note. Can you guess what are they from these table? Table number 5.3. I'm sure you got it. In the first column, he placed two elements together. What are they? Cobalt and nickel. Similarly, in the fourth column, he placed two more elements together. What are they? Cerium and lanthanum. If we talk about cobalt and nickel, these two elements are placed in the group of hydrogen, fluorine, chlorine, and bromine. These cobalt and nickel have very much different property than these elements. These two have different properties than hydrogen, fluorine, chlorine. We know that cobalt and nickel are metals, right? Whereas chlorine is a non-metal. Cobalt and nickel are metals, which means they have similar properties to metal. It has similar properties to iron, that is I. Iron, that is Fe. Fe is the symbol of iron. Okay, and you see where is Fe placed? In the last column. So if he arranged the elements with similar properties, then cobalt and nickel are very far away than iron. Iron is in the last column. So this way, this is the disadvantage, right? That the properties of elements are similar, but then also they are placed far away than each other. Also, cobalt and nickel are placed together to fit into the group. And then there was the discovery of noble gases, and then this Newland's octave became irrelevant. That is why Newland's law of octaves worked well with lighter elements only, which means which have lesser atomic mass. So up to that, up to which element it was proper? Up to calcium. So this you need to remember. Okay, if it is asked you in the exam that write examples of Newland's octave, so you can write that lithium, sodium has similar properties, then beryllium, magnesium has same properties, and it was worked properly till calcium element. Afterwards it was irrelevant. So this is all about Newland's law of octaves.